So because this length is L, from one force to the pivot would be half of L. Okay, so this therefore becomes the perpendicular distance. Then it means the turning effect is equal to the force, which is any one of it, because F1 is equal to F2. So F1 times half of the length would be the torque or the turning effect of the couple. So FL on 2 will be equal to it. Example, assuming this force is 100 Newton. Eliana, what will be F2? If F1 is 100 Newton and they create a couple system, what will be F2?
100 Newton.
Good. So this is also 100 Newton. Then the length, the common line or the distance between them is equal to maybe 50 centimeter. 50 centimeter, which is also half of a meter, right? Then the torque will be equal to 100 times 0.5 meter. 100 Newton times 0.5, which will be 50 Newton. Then it means, let's say 50 Newton. This is 5 on 10. So 50 Newton meter would be the turning effect of the couple or the torque. Please, are we fine?
Yeah, Mr. Edia.
Irene. Hey, Anita.
It shouldn't be 5 on 100.
5 on
100.
I said this is 50 centimeters. So 50 times 10 to the power negative 2. So 50 divided by 100. That is 0.5.
Oh, okay.
Don't forget, 100 centimeter is 1 meter. So 50 centimeter will be what? Half of it. So 0.5 meter. Anita, are you fine?
Yes, please.
All right. So we've discussed couple. Now, let's look at, so all that we are saying is that moment is a product of the force and the perpendicular distance. Now, we can have a situation where the force, either the force is not perpendicular or the length which has to be perpendicular is not. And in that situation or case, how do we calculate for the torque or the moment? Example, if I have this, a bar, a uniform bar, this is the pivot. Then we have a force F1. And from the pivot to where?
Mr. Edia.
Hello, Anita.
Mr. Edia, please, the formula for the torque, is it force times half of L or force times the full length of L?
It's half of L. It's half of L.
So the example, half of L was 50 centimeter.
I think that, yes, the whole bar at 100.
Okay.
So we have another hand is raised.
Yes, please. Sir, please, the half of L, isn't it a horizontal part?
Let me go back to the couple system again. So this is the center around which the turning takes place. So this is F1 and then F2. Okay. We are saying that let the whole length of the line, this line, the common line be L. What is a torque or moment? Moment is always the product of the force and the perpendicular distance. Perpendicular distance from the pivot, So if this is the pivot or the center around which the turning takes place, okay, it means to calculate the torque, it is this force times the perpendicular line the force makes from the pivot, this distance. Either this times the perpendicular line or the other one, okay? But what is the length of this? What is the length? This length is equal to half of L. Zanam, are you okay?
So, sir, please, that's the perpendicular distance.
Yeah, that's the perpendicular distance from the pivot. From the pivot, not from the other, not from the other force.
Okay, thank you.
Anita, are you fine?
Yes, please.
All right. So if I have this system where two forces, F2, F1 from the pivot is a distance A. F2 from the pivot is a distance B. Okay. Now the question is that calculate or determine the total, or sometimes the word the net torque. The net torque. Net because here we are considering a situation where they may not be the same. If the product of F1 and the perpendicular distance is equal to the product of F2 and the perpendicular distance, then we'll have the net force, the net torque around to be 0. But here, torque or moment is the product of, so we have this, you see, what is the direction of this? This is in an anti-clockwise direction. So we look for the anti-clockwise torque. And this is in an anti-clockwise direction. So we have equal to F1 times A, F1 times A. And what about the direction of F2? Is it clockwise or anti-clockwise? It's also going up. It's also going up. So once it's going up, then the direction is also anti-clockwise. So plus F2 times B. Therefore, the net torque in a system is equal to F1A plus F2B. Okay. Now, let's assume if a situation where F2 is acting downwards. If F2 is acting downwards, then what is the direction of F2? F2 acts in a clockwise direction, say downwards. So here, in a situation like this, the clockwise torque is equal to F2 times B, the anti-clockwise torque or moment. Is equal to F1 times A. Now, if T2 is greater than T1, then the net torque or moment will be equal to F2 times B minus F1 times A. Please, are we okay? Are we okay?
Sir, please, I'm confused.
We have, all that I'm saying is that we have two forces. We have two forces acting around the pivots. Okay, I've given you in the first situation or in the first consideration, I said, assuming F2 is acting going up and F1 is coming down. When you look at both, they all act along the same direction. This is going anti-clockwise. This is also going anti-clockwise. Please, do you understand this? So this is the same as having this and then me pushing this and you also pushing it up. Okay, both would eventually be in the same direction. Okay, I am pushing it down and you're also pushing it up. Eventually, the body turns along the same direction. So in a situation like this, if you are asked to determine the net torque or moment, net torque or moment, then because they are all acting in the same direction, the individual turning effect produced by F1 and F2 would add. So F1 times the perpendicular distance A plus F2 times the perpendicular distance B. So the net torque is this. Are you okay? Please, are we fine?
Yes.
Then another situation. This time F2 is not going up, but F2 is acting downwardly. Okay. Of course, this will give you anti-clockwise movement or turning effect. This will also give you a clockwise turning effect. So here, determine the anti-clockwise moment which of course is F1 times E. Determine the clockwise moment. Ado, are you there?
Yes, please.
Which is also F2 times B. Then, depending, this is the first torque, the first turning effect, and this is the second turning effect. Depending on the magnitude of this, T1 and T2, if T1 is greater than T2, T. Okay, I think T would help us. If T1 is greater than T2, then the net torque would be equal to T1 minus T2. So in this case, we'll have F1A minus F2B. If it's the other way around, that T2 is rather greater than T1, then the net torque or moment will be equal to T2 minus T1, which is F2B minus F1B. Okay. So that's all that I'm saying. So if you have a bar, okay, and there's a pivot at the middle, somebody is here, somebody is here. Whoever is here will create a clockwise movement. Whoever is here will create an anti-clockwise movement. Depending on the moment or torque produced by any of us, the net would either be here or here. So if I produce the greatest turning effect, which is the larger torque, okay, I will turn you in my direction. It will be this, okay. The net would act in the direction of the larger one, and so the direction of the net force will follow my direction. Okay, if you produce the larger torque, then the net would be in the direction of the larger one. Okay, as in forces acting, okay, against another force. Please, are we fine? Are we fine? Okay. All right. Now, what about if a force, there is a force, but the force is not directly perpendicular to the distance, or the distance is not perpendicular to the force? Example, I have this situation. I have this force F acting at an angle theta to this distance from the pivot. The distance from the pivot is L, but the force F acts at an angle theta degree to the distance from the pivot. You know, to determine moment or torque, all that I need is the force times the perpendicular distance. So here, either the force must be perpendicular to the distance, or the distance must be perpendicular to the force. But this force F is not perpendicular to the length L. Here, L is the distance. So I need a force which will be perpendicular to this distance to calculate. But it is inclined at an angle theta. How do I determine the turning effect or the torque produced by this? I hope you understand the question.
Yes, please.
Yes, ideas. How do we calculate for the turning effect here?
Maybe moment to be F times theta times distance.
Come again.
Force sine theta.
Cos sine theta. And why?
Because of the angle.
Okay. All right. That's a beautiful view. More views. I want more views. Any more observation as to how to go about Sanam
Sir, please, you find the y component
of
of the force.
okay and all right, okay. So nice contributions or observations so far. You see, since we are saying that moment or torque is the same, is the product of the force and the perpendicular distance. Yes, we have this length from the pivot, but to determine it, all that we need to achieve over here is to have a component of this force which will be perpendicular to the line. So if I could get something like this, a component of this force, F, okay, which will be perpendicular to the line L. So if I could create this situation, I can easily calculate for the moment or the torque, okay? So all that I do is that, look at, if we extend this line, this angle is theta. What will be this angle? Draw more, what will be this angle? If that angle is theta, what will be the other angle? Draw more.
180 minus theta.
Exactly. So this is 180 minus theta. Okay. What do you think will be this angle too? If the whole angle is theta, what will be this angle? What will be this angle? If this whole angle is theta, what will be this angle? You can see it.
Theta minus 90.
Exactly. This will be theta minus 90. Okay. So let's take it one after the other so that the rest of you can see very well. So this is theta. So if this is theta, then this will be 180 minus theta. Now, I want this component of the force, okay? Because that component is perpendicular to the distance. This is F. If I use this angle to resolve 180 minus theta, what I get for this side? Okay, let's judge what we get for this side. If the force is F, the angle is 180 minus theta. What do you think will be this side? Quick one. We've grown past it so quickly. Quick. Anita, what will be this component?
F sine 180 minus theta.
F sine 180 minus theta. Now this component, due to equal vectors, can also be brought here, isn't it? So if this is F sine 180 minus theta, this side will also be F sine 180 minus theta. Agree? I hope agree.
Yes, please.
Okay. So we've had the component which is perpendicular to this. Okay. The component of the force which is perpendicular. Therefore, moment or the turning effect, which is force times perpendicular distance, we have the force, which is F sine 180 minus theta times the length L. FL sine 180 minus theta. Now, let's look at what is sine 180 minus theta. The sine of an acute angle is equal to the sine of its obtuse angle. So sine 60 is equal to sine 120. Sine 30 is equal to sine 150. Okay, sine 20 degrees is equal to sine 160. This is the reason. If I have sine of a compound angle, A minus B, the expansion of this is equal to sine A times cos B minus sine B times cos A. The expansion of A plus A minus B. If this is a plus, all that will change is that the operator in the middle will change to plus. Okay, so that's the expansion of this. Now let's apply sine 180 minus theta, meaning my A is 180, B is theta. So I have sine of 180 times cos of theta minus sine of theta times cos of 180. Now, what is sine 180 degrees? Ladies, what is sine 180? 0. Once this is 0, everything is 0. So 0 minus, what is sine of cos of 180 degrees? Cos 180 is negative 1. So we have 0 plus sine theta, which is equal to sine of theta. So sine 180 minus theta is equal to sine of theta. So if I have sine, example, sine 180 minus 30 degrees, this is equal to sine of 30. But what is sine 180 minus? That's 150. It's equal to sine of 30. Please, are you okay? Are you okay with this?
Yes, please.
Okay.
Yes, please.
Meaning that if sine 180 minus theta is equal to sine theta, then this formula can simply be changed as, instead of 180 minus theta, all that we put there is theta. So this is equal to FL sine of theta. Okay. Now, when you consider the other angle, do I clean the board?
No, please.
All right. When you finish, tell me. Can we continue?
Please, I'm almost done.
Okay.
Stadia, please, I'm done.
Okay, so if we take the other angle, and that was the feedback Sanam gave us. If this is the whole angle is theta, then this angle would be theta minus 90 because this is 90. So 90, it means 90 plus this angle we don't know, x, must be equal to theta, the whole of this angle. This is 90. We are looking for this. So this plus this must sum up to be theta. Therefore, the unknown is equal to theta minus 90. So that's what Senna was talking about. If you use this angle, then this side becomes the adjacent, rather, okay? This side, the perpendicular component of the force we are looking for is the adjacent. So in that case, this side becomes F cos theta minus 90. Okay, so that perpendicular component becomes F cos. So that the torque or turning effect becomes F cos theta minus 90 times L. FL cos. So it actually depends on the angle you are looking at. Is that okay? It actually depends on the angle. Let's solve an example. Do I clean this? So we have this force F, whose magnitude is this. The length of this from where the force is to the pivot. This length is 2 centimeters. Okay, 20 centimeters. The angle the force makes with this point is 110 degrees. We are to calculate the turning effect produced by the force. Okay. Can you try? Give it a try first, okay?
Yes.
Okay.
All right. Finished. Finished. Do we look at it? Okay, so all that we are looking for is a component of this force which is perpendicular to the length. Okay. So in that case, or you see, in a situation like don't even stress yourself, eventually the torque or the turning effect produced will be equal to F